Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome you all the student of class 11 for our chemistry lecture. As we have started chapter number 8, that is elements of group 1 and 2. This is our second lecture for the same. In our previous lecture, we have studied about introduction, electronic configuration, and so on. Today we are going to study trends in atomic and physical properties of elements of group 1 and group 2. Here student, all the metal, they are which metal? Alkali metal. They are silvery, white and soft. Okay, due to their large atomic size, these elements have low density as well as they having low density because their atomic size is large. What is mean by size? Distance. Atomic size means the distance from the nucleus to the outermost shell. They are the most electropositive elements. They carry positive charge. Why? Because these elements tends to liberate an electron. We have studied this whole thing. What is atomic size? What is electropositive? Here the alkaline earth are metal. They are also in general silvery white luster. Okay, alkaline earth metal. Alkali metal means group 1 element. Alkaline earth metals mean group 2 elements. Okay, they are also having silvery white color and they are also soft, but they are harder than the alkali metal. We are comparing group 1 and group 2 elements. Group 2 elements are little bit harder than the group 1 elements. They are also strongly electropositive in nature. Similar to that group 1, they are also electropositive elements, but comparatively less electropositive than the alkali metal. Some atomic and physical properties of the alkali metal and the alkaline earth metal are listed in the table 8.4 and 8.5 respectively. We are going to study that table. Okay, later onwards. Here, group 1 element, that is alkali metal, group 2 element, that is alkaline earth metal. Both are having silvery white luster and both are soft, but alkaline earth metal, they are little bit harder than the alkali metal. Both are having strongly electropositive in nature. Group 2, that is your alkaline earth metal, is little bit less electropositive than alkali metal. This is the table which we are going to study. For group 1 element, lithium, sodium, potassium, rubidium, cesium, francium. Okay, here you see down the group. As we are moving down the group, the atomic radius is increasing. You see the value for lithium 152, then sodium 186, then for potassium 227, and so on. That the atomic radius is increasing. Okay, why? Because here the number of shell down the group, it is increasing. Okay, as we are moving down the group, the number of shell is increasing. Here we are not taking hydrogen, we are leaving behind the hydrogen. Okay, for group 1 element. Similarly for ionic radii, here also you see the ionic radii value down the group, it is increasing. As atomic radii and ionic radii is increasing, density will also be in increases. Ionization enthalpy is decreasing down the group. Here how atomic radii is increasing, because what is atomic radii? Atomic radii is the distance from the nucleus to the outermost shell. Okay, so here as we are moving down the group, number of shell is increasing. Fine, number of shell as atomic number is increasing, the numbers of electron is increasing, if number of shell is increasing. As the number of shell is increasing, the distance from the nucleus to the outermost shell is increasing, so its atomic radius is increasing. Fine. Similarly, ionic radii is also increasing down the group. Density is also been increasing down the group. Here ionization enthalpy is been decreasing. You have studied what is ionization enthalpy. Find the amount of energy required to liberate the most loosely bonded electron from the isolated gaseous atom. Here, ionization enthalpy is also been decreasing. Electronegativity, you're not supposed to study the value. Only study whether it is increasing or decreasing. Fine. Electronegativity is also been decreasing. Say the melting point is also been decreasing. Okay, in this way you are supposed to study. Now, physical properties of group 2 elements. Group 2 element, beryllium, magnesium, calcium, strontium, so on. Here, student, you see the value for atomic radii. It is 111, then 160, then 197, then 215, then 222. What do you find? Similarly, as what is happening in group 1 element, here also the atomic radius of the element is increasing down the group. What is the reason behind it? Same reason what is in group 1. Here the what is happening? The atomic number is increasing. So your number of shell is increasing down the group. As we are moving down the group, number of shell is increasing because one element is belonging to second period, then third period, then the next one is belonging to the third period, then further is belonging to the fourth period. We have studied the element which belongs to the second period contain two number of shell. The third period elements belong to containing three number of shell, and so on. So as we are moving down the group, the atomic radius is increasing. Why? Because the number of shell is increasing. Similarly, ionic radii is also being increasing down the group. And density, as atomic radii, ionic radii is increasing, its density will also be increases. Ionization enthalpy, we have studied what is first ionization enthalpy, what is second ionization enthalpy, the amount of energy required to liberate the first class electron. Second ionization, the amount of energy required to liberate the second last electron. So here the ionization, as you see, for first ionization enthalpy and second ionization enthalpy, it is being decreases down the group. Atomic radii, ionic radii, density, it is been increasing down the group, while ionization enthalpy is being decreases. Here electronegativity is also being decreases down the group. Melting point is also being decreases down the group. So here student, unipositive ions of all the elements of group 1. Unipositive means carry plus 1 charge. Of group 1 have inert gas configuration. Thus they have no unpaired electron. Group 1 elements, if they use 1 electron, okay, then it will be getting converted into plus 1 and they will be having inert gas configuration. Hence, they do not have any unpaired electron. As they do not have unpaired electron, these compounds are dimagnetic and colorless. Okay, these compounds will having the properties of dimagnetism and they will be colorless. So the divalence ions of group 2 elements also have inert gas configuration. Okay, here group 2 elements, they are also having inert gas configuration as they do not have any unpaired electron. Hence, they also being diamagnetic in nature and they will be colorless. Okay, same what is the property of group 1, that is, as they will be converted into unipositive ions, they will be having inert gas configuration. Inert gas configuration means who are inert, group 18 elements. So they will be similar. Their electronic configuration means they do not have any unpaired electron. So they will be having similar configuration to those of group 18 elements. Here group 2 elements will also be having no unpaired electrons. So they will be having inert gas configuration and no unpaired electron and behaving as dimagnetism in nature, and group 1 and group 2 both will be having dimagnetic in nature and colorless. Okay, Lithium and beryllium differ from the rest of the elements of the group 1 and 2. Who will be differ? Because they are extremely having small size and comparatively high electron negativity. Here two elements. One is lithium and another is beryllium from group 1 and group 2. They will differ from rest of the element. Why? Because they are having extremely small size and high electronegativity. So here student, the physical properties of group 1 and group 2 element show reasonably regularity in the periodic trends. Means what is the periodic trends? For the trends means whether it is increasing or decreasing. So group 1 elements and group 2 elements is having the similar trends. Okay, here atomic radius is increasing for group 1 as we are moving down the group. For group 1 atomic radius ionic radius density is increasing. Similarly for group 2 it is increasing. Fine, ionization enthalpy electronegativity both are decreasing down the group in both the group. Okay, so here the atomic and ionic radii and density is increasing down the group. What is happening, student? Atomic radii, this is the most important point what you are supposed to learn, what you are supposed to remember. Atomic radius is increasing, ionic radius is increasing, density is increasing. Where it is increasing? Down the group for group 1 as well as for group 2. While ionization enthalpy, electronegativity decreases for both the group, that is your group 1 and group 2. Thus the elements of both these groups in general have high negative value of standard reduction potential. Okay student, you are supposed to remember this important terms that atomic radius, ionic radius, density is decreasing down the group. You are not supposed to remember the value. Only remember what is happening down the group. While ionization enthalpy, here atomic radius, ionic radius, density is increasing down the group, while ionization enthalpy and electronegativity is being decreases down the group. Hope you all have understood, student. For today, we have studied this topic, that atomic radii, ionic radii, density is been increasing down the group for both the group, while ionization enthalpy, well, melting point is been increasing, decreasing down the group for group 1 and group 2. Hope you all have understood. Till then, take care students, study well, do your best. Allah Hafiz.